welcome to my channel. Today we're going to be going over transcription, so let's get into it. Basically, we're going to have a DNA strand and an RNA strand. We know that a DNA double helix is called a double helix because it's kind of shaped like this. Shaped like this. Within these two strands that we have things called nucleotides. Of nucleotides, those are one of the biological molecules. Our nucleotides make up our DNA strands. So our nucleotides consist of adenine, guanine, thymine, cytosine. These are all present in DNA. Now, if you know the rules of complementary base pairing, A goes with T and C goes with G. That's the rule in DNA. And I'm labeling this DNA for a reason because we do have a change when it comes to RNA. When we get into RNA, our nucleotides are different. We have adenine, guanine, we have cytosine. We don't have thymine in RNA, we actually have uracil. And if you don't know, uracil is less stable than thymine, so we prefer thymine over uracil. So uracil is less stable, and this is in RNA. And the complementary base pairing goes as follows. It pairs with U. Since there's no T, it's going to pair with U, so uracil replaces thymine. And then we're going to have C to G. Same for both. Now that we went over that, I'm going to go into what it looks like transcription, because I know a lot of students get transcription and translation mixed up. I want you to think about it like this. Transcription comes first because transcription has a C, and translation has an L, and C comes before L. So you can think of it like that. We are going to draw a DNA strand. I'm gonna create kind of a random sequence. We have our first strand of DNA, right? And we need complementary base pairs with this to make a double helix, because right now this is just one strand. This is just one strand. We need another strand to make that double helix. Make another strand. And this strand is going to pair with the others via complementary base pairing. I have the rules here. And then we'll have C. So based off of these rules, we're going to pair. So A goes with T, T goes with A, vice versa, right? So these go this way and that way, this way and that way. So they go both ways. So C goes with G, and G goes with C, and C goes with G, and A goes with T, and T goes with A. Boom. We have, this is a DNA double helix here, but it's just in kind of simpler form. But since we have two strands, it's gonna look like this now. So we have like the two, so that's where you see that like connecting, and you would see those nucleotides like in between on each side. So that's what this is showing, but just on a simpler level. Now, when we're talking about transcription, we are taking this bottom strand of DNA, okay? I'm not going to go into deep details about it. I just want you to understand what is happening. We are going to create a mRNA strand based off of this strand here, okay? I want to go into RNA polymerase. I'm going to draw the same drawing that we had, but I'm going to include RNA polymerase. RNA polymerase, basically what RNA polymerase does is it creates that mRNA strand that's going to come out of this enzyme. Remember guys, anything that ends in ACE is an enzyme. Okay, so it's going to come out of this enzyme and we're going to have our nucleotides. This is mRNA. The sole function of RNA polymerase is to make mRNA. Makes sense, right? Because RNA makes mRNA. So, mRNA just stands for messenger RNA. Next video, I'll do exons and introns and show you how we produce that mature mRNA. T, in this instance, is going to be replaced with uracil. So do you remember when I was explaining to you the pairs earlier? So this would be A to U and then C to G. The C to G stays the same in both. Because A goes with U, C goes with G. But these don't go the same way since in RNA there's no thymine. Okay, and I only have this T here because there's a T in this DNA strand, which makes sense because DNA has thymine, but RNA does not. So we have TA, and then A goes with U, right? G goes with C, and then C goes with G, and then G goes with C, T goes with A, and then we have our two A's at the end, which go with U. Okay, and this process is transcription. This is literally what it is. We are transcripting this bottom DNA strand, right? And we're converting it into an RNA strand, essentially, is what we're doing. Some people get confused on the rules of complementary base pairing with RNA, but just make sure to keep this to memory, because this is very important, both of these. Transcription is only the transcripting of this bottom DNA strand and converting it into RNA. DNA to RNA. That's what transcription is. And it doesn't matter what science class you go into, you're gonna have to know this. Even in upper level courses, you will have to know this. If you have any questions, please let me know in the comments, and don't be afraid to give me some feedback, because this is my first video. I know it's a little short, but I really appreciate you guys coming and watching this video, and I hope to see you in the next one.